Let's start with motion in a plane. Okay, and now what is difference between motion in a straight line and motion in a plane? So on straight line we need only one coordinate, right? If there is an object who is moving along a straight line only, we need only one coordinate. But if there is an object who is moving on a plane, in order to locate that object we'll need two coordinates. Okay, so suppose you can consider your table, it's a plane and there is some ant moving on that table. Okay, and you want to locate that ant, so you can consider any corner of that table, that will be your origin. Okay, draw a line, or side of the table, it will be what, x-axis, another side will be y-axis. Okay, start looking from that corner. So you will need two coordinates, x and y. So this is initial position, okay, given by x0 y0, and this is suppose the final position. Okay, so it is x at time t and y at time t. Okay, so now there are two ways. So either we can keep track of these coordinates, or we can keep track of the distance of that point. Okay, the distance of the position of the object with respect to the origin, right? So what we do is we join origin with the position of the object, okay, and we call this as position vector. Okay, we call this as, we draw an arrow from the origin to the position of an object and we call this as the position vector. Okay, so this is the initial position vector, and this is the final position vector. If I join this line, this will be the final position vector. Okay, this is final position vector. So now what is a vector? Vector is an arrow drawn in space. Okay, vector is an arrow drawn in space starting from some position, we can say. Okay, and it can be used to denote the position, the displacement, or various other quantities, right, which has got magnitude, which have got magnitude as well as direction. Okay, so vectors are arrows drawn in space and they are used to represent various quantities which have magnitude as well as direction. Okay, so then there are other quantities which have magnitude but no direction. So there are some quantities which have magnitude but they don't have direction, and there are some quantities which have magnitude as well as direction. Okay, so for an example, these quantities which have magnitude only, they are known as scalars, and the quantities which have magnitude as well as direction, they are called as vectors. Okay, so examples are, distance is a scalar quantity, speed is a scalar quantity because speed is just distance divided by time, work is a scalar quantity, energy is scalar quantity. Okay, so work has only magnitude, it doesn't have a direction, right? Energy has a magnitude, it doesn't have a direction. Then the physical quantities which have magnitude as well as direction is displacement. Okay, the position also, position will have a direction because you will find position with respect to some reference point which is known as origin. So the position will have some direction because it is an arrow drawn from the origin to that point. Okay, so position is a vector, displacement is vector, velocity, acceleration, force, momentum, and many more quantities are there which are vectors. Okay, so now see, we'll see vectors in brief. So this is suppose a vector quantity. Okay, so I have considered a force of 5 newtons suppose, and I'm drawing that using an arrow. So this arrow of this much length, it shows force of 5 newtons. Okay, so obviously if I break it into 5 parts and if I consider any one part of them, then that one part will represent what? Force of 1 Newton, right? It will be in same direction as that of this arrow. Okay, so this one is known as a unit vector. So unit vector is a vector having magnitude of 1 unit, okay, and in a specific direction. Okay, so how do we find the unit vector? So I can say that this f bar, okay, we represent vectors like this. Okay, f is for force and we put arrow on top of f. So f bar means force vector, it's equal to 5 newtons. But I can say that this f bar is equal to what? So if I take 5 such small vectors, unit vectors, I will get f bar. So it is 5 times f cap. Okay, and what is magnitude of this f bar? So magnitude is written like this. Okay, magnitude is written like you keep that vector quantity in absolute sign symbol. Okay, absolute symbol. So this represents the magnitude. So magnitude is equal to 5 newtons. Okay, so then if you consider this vector f cap, this is known as the unit vector in direction of f bar. So what is a unit vector? It's a vector having magnitude of 1 unit. Okay, and now see, magnitude of this f bar is equal to 5. So I can write this equation as f bar is equal to magnitude of f bar multiplied by f cap. Okay, so a vector can be written as its magnitude multiplied by unit vector in that direction. Okay, a vector can be written as its magnitude multiplied by unit vector in that direction. So from here you get definition of unit vector. So unit vector can be written as what? Take this magnitude on the other side. So it is f bar divided by its magnitude. Okay, it is f bar divided by its magnitude. So is this thing clear to everybody?
Yes, sir. Yes, sir.
Okay, so this you might already know. I just want to make it sure. Okay, now next is unit vectors. So what do you mean by unit vectors? So now this is like a common sense. What is meant by unit vectors? Sorry, equal vectors. What do you mean by equal vectors? So this is a common sense. Two vectors can be called as equal if their magnitude is equal and their direction is same, right? Magnitude is equal and direction is same. So this is a bar, this is b bar. They are pointing in same direction. Their length is equal. So these two vectors are equal. Okay, and what about this one? So can I say that a bar is equal to c bar? This is also pointing in the same direction, but it's not along the same line.
Yes, sir.
Okay, so here that's correct. So in physics, the vectors that we consider, they are known as free vectors. So what do you mean by free vector? You can take a vector and you can move anywhere in space. Okay, just don't change its direction, then the meaning of that vector will remain same. Okay, so this vector over here and vector over here, it means the same thing. Okay, so two parallel vectors are also equal, right? So we consider free vectors. So there are another type of vectors which are known as fixed vectors. Okay, so fixed vector, it will be pointing in same direction and you cannot move it in space, right? So we consider most of the times free vectors, and these vectors, they are considered to be equal. So a bar is equal to b bar is equal to c bar if the magnitude is same and direction is same. Okay, so not unit, equal vectors is clear.
Yes, sir. Yes, sir.
Yes, sir.
Okay, next is zero vector, or it is also known as null vector. So what is zero vector or a null vector? So if you take some vector operation, Vector operation meaning if you have two vectors, you add them, you subtract them, you multiply them, or you divide, and the result is 0. Okay, the result is 0. Now this is a vector operation. Especially when you do vector addition or subtraction, the resultant must be what? It must be a vector, because if you are adding two vectors, resultant must be a vector quantity. Okay, so for an example, you add displacement and displacement. So you move from one place to some place, okay, A to B, and you move from B to C. So displacement from A to B plus displacement from B to C must give you what? The final displacement, the total displacement, and it's also a vector quantity, right? So therefore the resultant, okay, the result of vector operation, okay, it is represented by 0, and we put a bar on top of that, so it is known as 0 vector. Okay, so what does this mean? If you have got a 0 vector, does it mean that it is pointing in some direction? No, it doesn't have a magnitude, it doesn't point in any direction, it's a 0. But this means that it is the result of operation of I'm sorry, okay, so this is all right. So this, just a second. All right, so this means that it is result of what? The addition or subtraction of two vectors, right? This means that it is result of addition or subtraction of two vectors. That's it. Okay, so this is clear, 0 vector.
Yes, sir.
Okay, let's see the addition of two vectors. So now let's suppose this is one vector. So for an example, I'm here and I'm moving. Okay, so suppose I start from here, from point A, and I move from point A to B. Then I stop there. Again I move from B to C. So this is my displacement. Okay, I call it S1 bar. This is another displacement. I call it S2 bar. Okay, and what is my net displacement? So if I draw a straight line starting from the original position or initial position to the final position, that's my total displacement. So that is R bar, right? So this R bar is equal to S1 bar plus S2 bar. Okay, it is equal to S1 bar plus S2 bar. If I add two displacements, two partial displacements, I should get what? The total displacement, right? So this is resultant of addition of these two displacements. Okay, and if you think about this, it gives us a law. This law is known as the triangle law of vectors addition. Okay, and what does this law mean? So if there are two vectors and they are represented by two sides of a triangle, you have two vectors, they are represented by two sides of a triangle taken in an order. This is important, taken in an order. So it means that the first vector ends at some point, second vector will start at that point. Okay, so if you represent two vectors by magnitude and direction, in magnitude and direction by two sides of a triangle taken in an order, then the resultant is represented by the third side of the triangle, starting at the start point of first vector, ending at the end point of second vector. This is clear?
Yes, sir.
Okay, everybody please reply.
Yes, sir.
Okay, so this is triangle law of vectors addition. Okay, R bar is equal to S1 bar plus S2 bar. So now we can make use of this triangle law to subtract two vectors also. How are we going to do that? So what we do, so let's suppose I want to subtract this s2 bar from s1 bar. What I will do is, so this is my s2 bar, I will just tilt it in the opposite direction. Okay, I will get minus s2 bar. So this is s2 bar. If I draw a vector in opposite direction having same magnitude, that will be minus of s2 bar. So I will add s1 bar and minus s2 bar. See, I am adding only s1 bar and minus s2 bar. So what I am getting is s1 bar minus s2 bar. So this vector plus this vector is this vector. Okay, so we can add two vectors or subtract two vectors using the triangle law of vectors addition. Okay, so we'll see the formula for this addition and subtraction. Next, now suppose we have n number of partial displacements. Okay, so triangle is not sufficient, we'll need a polygon to find out the resultant displacement. So for an example, this is suppose partial displacement from A to B, then I move from B to C, then I move from C to D, then from D to E. Okay, so now see, these are S1 bar, this is S2 bar, this is S3 bar, S4 bar. If I add all of them, so there is a law which is known as Polygon Law of vectors addition, which says if you have n minus 1 vectors represented by the n minus 1 sides of n sided polygon. Okay, there are n sides, but you are representing n minus 1 vectors by n minus 1 sides. So in this case you have 1 2 3 4 5 sides. So okay, this is pentagon, 5 sides, right? And you are representing 4 sides of this polygon, okay, using 4 vectors, and you take them in order. Then the resultant is represented by the remaining side. So this is the remaining side, so this will be the resultant. Okay, that is, it is equal to what? S1 bar plus S2 bar plus S3 bar plus S4 bar. Okay, and it will start at starting point of first vector and it will end at, or it will point to the end point of last vector. This is clear?
Yes, sir. Yes, sir.
Okay, so this is known as Polygon Law of vectors addition. Alright, so now let's come to resolution of two vectors. Sorry, not resolution of vectors. Now let's come to resolution of vectors. So suppose you have some vector r bar, and if you write it as addition of two vectors, so here r bar is equal to this a bar plus b bar, then we say that r bar is resolved into a bar and b bar. This is just resolution. Resolution meaning representing a vector by addition of two or more vectors. Okay, so this one is known as the resultant, okay, the vector that you resolve, and these are known as the components of the vector. So a bar and b bar, they are known as components. Okay, so if you add these two component vectors, you get this resultant vector, or you can say r bar is resolved into a bar and b bar. So now r bar can be resolved along any two vectors, okay, or any n vectors I can say, right? But there is one specific type of resolution that is very helpful, and it is resolution in rectangular components. Okay, it is resolution in rectangular components. So this is r bar. Now what we do is we resolve it along two components, two rectangular meaning perpendicular. Okay, so this is one vector, I will call it rx bar. This is another vector, I will call it ry bar. So I can say r bar is equal to rx bar plus ry bar using what? The triangle law of vectors addition, right? So then this ry bar can be drawn here also. Okay, ry bar can be drawn here also, right? Because this is concept of unit vectors, sorry, why I'm saying unit only, equal vectors. This is concept of equal vectors. Okay, two vectors are equal if they have same magnitude and same direction, they are pointing in same direction. Okay, so now see, this r bar is resolved in these two vectors, one along x-axis you can say, and the other one along y-axis. Okay, so r bar is equal to rx bar plus ry bar. So magnitude of this vector rx bar is equal to rx, magnitude of ry bar is suppose ry, magnitude of rx bar is rx, magnitude of ry bar is ry. So we can write rx bar is equal to what? Its magnitude multiplied by unit vector in that direction. Okay, the vector can be represented as its magnitude multiplied by unit vector in that direction. So rx into I cap. So what is I cap? It is unit vector in x direction. Okay, similarly ry bar can be represented as its magnitude multiplied by unit vector in y direction. Okay, so you have r bar equals to rx into I cap plus ry into j cap. Okay, and now how can we find out rx and ry? So this angle is theta. Okay, so this is a right angle triangle. So in this right angle triangle you can find out this side and this side, right? So rx will be equal to r cos theta, ry is equal to r sin theta, right? So see, in this one I can find out cos theta. So what will be cos theta? Adjacent side divided by hypotenuse. So cos of theta is equal to adjacent side upon hypotenuse, and therefore rx is equal to what? It is r cos of theta. Similarly you have sin theta equals to opposite side divided by hypotenuse. Okay, so that is you have ry equals to r sin theta. Okay, so then so you have rx is equal to magnitude of rx bar, which we find as r cos theta, and ry is equal to r sin theta. Okay, and therefore we can find out this angle also in terms of rx and ry. So suppose this angle is theta, I can find out tan of theta. So tan of theta will be equal to what? Ry divided by rx. Okay, tan of theta will be equal to ry upon rx. So theta will be equal to tan inverse of ry upon rx. So this is clear. All right, so then okay, so if I want to find out its magnitude of resultant, okay, so I can use Pythagoras theorem. So I will have r square equals to rx square plus ry square. Okay, r square equals to rx square plus ry square, and therefore r will be equal to square root of rx square plus ry square. Okay, this is the magnitude of resultant, right? So this is resolution of vectors along two components. Similarly we can extend this to three components. Okay, so this is resolution in a plane. If you have a plane, you will have resolution like this. Now similarly I can resolve a vector. This is a vector, I can resolve it along three directions. Okay, so okay, I can resolve this vector along three directions. So r bar can be written as rx bar plus ry bar plus rz bar. Okay, so r bar's magnitude will be equal to square root of rx square plus ry square plus rz square. Okay, and rx bar, ry bar, rz bar, they can be written as rx into I cap, ry into j cap, rz into k cap. Okay, all right, then let us see next topic, the parallelogram law of vectors addition. So what is parallelogram law of vectors addition? So you have some vector r bar and you resolve it in two vectors. Okay, So suppose r bar is resultant of addition of p bar and q bar. Okay, r bar is resultant of addition of p bar and q bar. So we saw how can we add p bar and q bar using the triangle law of vectors addition. Okay, so now see, if I draw this q bar at this point, okay, I will get this vector, and if I draw a p bar at this point, I will get this vector. So if I consider this diagram, it's a parallelogram. Okay, so now r bar is p bar plus q bar. R bar is equal to p bar plus q bar. Okay, so it can be shown as this addition can be shown in this triangle also, or this addition can be shown in this parallelogram also. Okay, so then you have the resultant r bar, and if you want its magnitude, so its magnitude is given by square root of p square plus q square plus 2pq cos of theta. Okay, so magnitude of this resultant is given by square root of p square, magnitude of first vector square plus magnitude of second vector square plus 2 times the magnitude of first vector multiplied by magnitude of second vector multiplied by the cos of the angle between two. Okay, and now suppose this resultant makes an angle alpha. Suppose it makes an angle alpha with the first vector, then that alpha can be found out using tan inverse of q sine theta divided by p plus q cos of theta. Okay, so this formula, do you know this formula, this one and this one?
Yes, sir.
Okay, so we have to remember this formula. Okay, and now suppose it makes an angle beta with this one. So can you find out beta then? Yes, no? So see, what is alpha? Alpha is angle between this first vector and r bar. Okay, beta is angle between second vector and r bar. So what's the difficulty? Just replace first by second one, second by first one. Okay, so I can find out, if I know formula for alpha, I can find out beta also. It will be tan inverse of, see, I can say this is first vector, this is second vector. I can also say that this is first vector and this is second one. Okay, and I can find out angle between these two. So where you have q, just make it p, and wherever you have p, just make it q. So you will have p sine theta. Okay, here it will be p sine theta divided by, you have p, make it q, q plus p cos of theta, right?
Yes, sir.
Okay,
Yes, sir.
okay, good. So you can find out beta also. So this is parallelogram law of vectors addition. Okay, so I wrote that formula here, and there is another rule which might be useful sometimes. Okay, and that rule is known as the sine rule. So what is sine rule? See, in very simple language, sine rule is, if you have these three vectors p, q, and the resultant is r. Okay, so angle between p and q, how much is the angle between p and q? It's theta. Okay, so the magnitude of resultant, magnitude of one vector divided by angle between other two vectors is equal to, now pick any other vector, okay, divided by, so see, you have r, you have picked r, so magnitude of r divided by sine of the angle between other two is equal to magnitude of p divided by sine of the angle between other two. It is equal to magnitude of q bar divided by sine of the angle between other two. Okay, alpha is angle between p and r, right? The other two. Got it? Yes, no?
Yes, sir.
Yes, sir.
Okay, so this is how we can remember the sine rule. So sometimes this formula will be Okay, this formula, or you can say this formula will be helpful. Sometimes this might be helpful. Okay, so for an example, okay, this you can use when you know P and Q, and you want to find out when you know P and Q and angle between them, and you want to find out the angle between resultant and a vector. This will be helpful when you know, suppose, the resultant and a vector, okay, and angle between the resultant, so angle between the other two. Okay, so in some cases this formula might be useful, or you can see this one. So actually this is a simpler formula. Okay, so this is just comparison. Here you have to find sine theta, you have to find cos theta. In this one, okay, sine theta, cos theta, and then you will have to take tan inverse, right? So in this one you have to see sine and sine only. Okay, so here there are 3 operations, here there are 2 operations. Okay, so in some examples this one will be useful. Okay, in some this one will be useful, depends upon the cases, right? But we need to remember both of them. So is it clear?
Yes, sir.
Okay, now let's come to the examples. So let's start with very simple one. Which of the following is not a vector quantity? Tell me.
Weight, sir.
Weight is a vector.
Option B, sir. Nuclear spin.
It's also a vector. It's option D. Okay, spin is a vector quantity. So yeah, so you learnt it in chemistry, no? How do you represent a spin of a vector? The up spin, down spin. You represent it like this? Yes, no?
Yes, sir.
Yes, sir.
Okay, so you are using an arrow to represent it. It's a vector quantity. Okay, and then I'm sorry. If spins are okay, if you have what do we say, that if you have electron pair, their spins get cancelled out. Okay,
Yes, sir.
so spin of first one is up, suppose the spin of second one will be down, and that's why net spin will be 0. Okay, alright, so this is a vector quantity. Then weight, what about weight? So you have some person, what is the weight? It's the gravitational force.
How much, sir?
Yeah, it's a gravitational force, so it always acts downwards, or we can say towards the center of earth. This is also a vector quantity. Momentum is a vector. So energy is a scalar quantity. Okay, so it's option D, right? So this question you have to understand. So which of the following statements is true? So now you think whether you can answer. Which of the following statements is true? Option A, when the coordinate axes are translated, the components of vector in a plane changes. When coordinate axes are rotated through some angle, components of vector change, but the vector's magnitude remains constant. Option C, sum of A bar and B bar is R bar. If the magnitude of A bar alone is increased, the angle between B bar and R bar decreases. And option D, the cross product of 3i and 4j is 12. So can you guess?
Sir, is the answer option B?
Option B is when coordinate axes are rotated through some angle, components of vector change, but the vector's magnitude remains constant. Yeah, this is true. Correct. So see, I have drawn it here. Okay, when coordinate axes are translated, components of vector in a plane changes. So actually, if you have these two coordinate axes, okay, and if you translate Translate means you move them. So will the components change? Yes or no?
No, sir.
Components will not change, right? So see,
Yes, sir.
right. So even if you move them, the coordinate axis, their directions will remain same. Okay. So one will point along x, the other one will point along y only. It doesn't matter whether you move the coordinate axis like this or like this. Okay. Still, one will point towards x, other will point towards y. Okay. So therefore, if you find the components of a vector along these two, they will remain same. Okay. Next one, when the coordinate axes are rotated. So see, I have drawn it here. So you have this vector and you resolve it along x and y coordinates. So you will draw perpendicular from tip of this vector. So this is your rx, this is ry, right? So this much is rx, this much is ry. Now you rotate the axis. So your new x-axis is this one, I will call it x dash. New y-axis is this one, y dash. So now if you find out the components, so this much will be your rx, or you can say this is rx dash, and you can compare rx and rx dash. They are not equal, they are changed. Okay, and this one will be your ry dash. Okay, but now components have changed, but the magnitude of this vector, it will not change, right? What is magnitude of vector? Magnitude of vector is the length of the vector. So you are rotating axis, you are not stretching or doing anything on the vector, so therefore its magnitude will remain same. Okay, so that's the explanation. So good, Sai. Is it clear, Raghu?
Yes, sir.
Okay, so this is option B. Let's see next one. If a bar plus b bar is equal to, if magnitude of a bar plus b bar is equal to magnitude of a bar plus magnitude of b bar, then the angle between a and b will be?
Option C, sir.
It's option C, right, Raghu? Alright, you have a bar and b bar, two vectors, you are adding them. Okay, so now we can solve this using this formula. R is equal to square root of a square plus b square plus 2ab multiplied by cos of theta. Okay, we can solve it like this, but there is a simple way actually. See, so okay, let's solve it this way. So this is magnitude of the resultant, okay, and it's equal to a plus b. So if it is equal to a plus b, what does it mean? That what will be a plus b in square root sign? It will be square root of a plus b square. Okay, so what I am saying is, if you square it, it will be equal to a square plus b square, plus you want 2ab here, because a plus b square is a square plus b square plus 2ab, but you have this cos of theta in multiplication with 2ab. That means cos theta must be equal to 1. Okay, so if cos of theta is equal to 1, that means theta is equal to what? 0.
Yeah, okay, sir.
Right? But this is lengthy way, we can say. Okay, so if you add two vectors and resultant is equal to what? The magnitude of first vector plus magnitude of second vector. This can be done in only one way. So see, you have this a bar's magnitude and b bar's magnitude. Okay, so this is the resultant. Okay, so magnitude of resultant is equal to magnitude of a plus magnitude of b. It can be done in this way only if the angle between them is 0. Okay, right? If you put two lines, okay, if you put two lines having some lengths, so the total length or length of the resultant will be equal to length of first one plus length of second one only when they are kept in a straight line. Okay, you keep b bar in any other direction, you keep it like this. So if this is b bar, so now this is your r bar. So now question is, okay, there is some angle between a and b. So now this r's magnitude, will it be greater or will it be lesser? So is this thing correct or is this thing correct? First one is correct or second relation is correct?
Second relation.
Good, second relation is correct. Okay, so in any other case it will be less than the magnitude of a bar plus magnitude of b bar. Okay, so what's the general relation? So general relation is this one, that magnitude of the resultant is less than or equal to magnitude of first vector plus magnitude of second vector. So equal to in only one case, when the two vectors are kept in front of, in a straight line, right? Okay, so there can be question based upon this thing also. Okay,